So looking at gaseous exchange in the lungs, this is where we're concentrating on the two gases, CO2 and oxygen, and how we can get more of that or remove it. So the process involves diffusion, and this is where we have areas in the body that allow a gas to move across a capillary wall. So the first place is in the lungs, in the alveoli, where we can get oxygen across from the lung into the bloodstream, and then get that to the muscle, where that can then go from the capillaries into the muscle. And then beyond that, we're picking up carbon dioxide generated from the muscle and then taking that back towards the lungs, where it is then again diffused to go back into the lung and then be expelled. So looking at the concentration levels in the lungs, we need to move a lot of oxygen and a lot of CO2. Now, we don't do that. This is just, it's not something we are in control in. Gas has its own laws. So diffusion is where gas particles will move from an area of a high concentration to an area of low concentration. So the oxygen molecules don't like being crowded. You know, it's hard to move around. We need space, and then as soon as it sees a place that there's, there seems to be more space over there, it will naturally move across to have its own little space, and it's a bit easier to move about. So in the bloodstream, when it's picking up carbon dioxide from the muscle, what will happen is because there's such a high concentration of carbon dioxide in the bloodstream, the venules, then the veins, when it gets to the lungs, there's a low concentration of carbon dioxide inside the lungs, and therefore the natural movement for carbon dioxide is to just change over and go back into the lungs for it to be expired. Our percentages are a bit different. So oxygen, we're breathing in about 21% of that, but we only use 5% of it. So we are breathing out 16% of what we already breathed in. So we don't use a lot of it. However, in terms of what we actually make, we produce quite a lot of carbon dioxide. So 0.04% is what is breathed in. But then when we breathe out 4%. So we do produce quite a lot of carbon dioxide. And this is where the importance of diffusion comes in, because the venules and veins carry a lot of carbon dioxide. So there's much more of an importance to remove carbon dioxide than there is to get oxygen in, because we've already got a fair amount of oxygen in the body as we're breathing. So there's a massive emphasis on removing this toxic waste from the body. So diffusion, we need to pass through a cell membrane, and this can happen whether it's going into or out of a cell. And as mentioned, it's a law of its own. So gases will naturally go from a high concentrated level to a low concentrated level. So there's more space for it to breathe and move about. So yeah, I mean, some people can be claustrophobic. They don't like big crowds, people getting too close to the face. So there's a natural cause for a human being to move into where there is more space to operate, to move around. They feel like they can breathe and work and things like that. So that's a good way to think about it. Now, you've got one of these in your books. So in terms of what the blood flow that's coming in, this very low in oxygen, but very high in carbon dioxide. And as it travels through, this is where it has the opportunity to go to travel across, because there's a low concentration of carbon dioxide here and a high concentration. So it doesn't like, it's too claustrophobic of carbon dioxide here. So it jumps over and is allowed to be expired. Same thing with the oxygen. Very high concentration levels inside the alveoli of oxygen, very low levels of oxygen in the bloodstream, and so the gas will naturally move across. So thankfully, the alveoli have very thin walls that have millions of capillaries surrounding them. And as I think we've mentioned before, you've got about 3 million alveoli sacs inside the lungs. And this allows the body to be able to move gases across. So these capillaries will carry blood that includes CO2 and O2, and this semi-permeable membrane allows only certain things to be moved in and moved out, mainly O2 and CO2. So within the alveolar wall, gas is brought in, and then within the capillaries we've got blood. Blood will always be within a vessel, okay? So it's always within a capillary, and it's waiting to either drop off CO2 or pick up oxygen. And the membrane is specifically designed to exchange this gas. Now, the body likes balance, and if there's a high concentration of one and not the other, then it's not balanced. And therefore, that's where you'll then get a change in your breathing rate to try and accommodate this change. So if there's too high a CO2 content within the lungs or within the bloodstream and the body, then your breathing rate will change in order to try and get rid of it more. And then you'll also be breathing in more oxygen to keep that balance level. Now, we don't come to this till next year really in terms of the affinity of blood. Blood has a special need for oxygen, and that can be changed. So during exercise, the blood becomes very needy and wants more oxygen,